Okay. Multiprocessing in fourth, take two. Hopefully this will be a little clearer. Um, so up here we have four tasks. All they will do is print their number, 0, 1, 2, 3 respectively, and when they're done printing their number, they will tell us that they're done, and that will be the end of the task. I'm a little sick today, so excuse my voice. Then we will just, I will print out the dictionary so that you see these tasks in the dictionary. Then I will run them in sequence, one by one. First this one, and then the next one, and then the next one. And what you should see then will be the numbers. First there will be 30 zeros, 31s, 32s, 33s printed across the screen here, ending with a carriage return. Then comes the interesting part. Instead of executing these tasks, I will spawn them as as processes, and that means that if you have 4 CPUs running these 4 tasks will be just as fast as running one of these. On my system I have 56 CPUs, so I could actually have 56 tasks here and have them run concurrently in the same time as it would take to run one on a single thread. And then down here I will just go in a loop to wait for them to finish. Otherwise, if the program exits before the tasks are finished, they might end prematurely. I'm not sure about this, but I did it. So let's run them. So here you see the tasks in P code form. They get compiled to P codes, and it's the P codes that run in tasks. And here you see them run in sequence. You see the number of zeros, you see that task 0 is done, number 1, number 3, etc. Everything nice and orderly and no surprises there. But then we run them at the same time. And here you see I start task 0 first, so it begins to print. But then task 1 starts, so it starts to print its ones, and it continues like this until task 0 is done. Then it prints task 0, it prints a carriage return, so we get a new line here. Task 1 is not finished yet, and now task 2 starts up. And then now task 1 is finished, so it prints its carriage return and says that it's done. And now it's task 2 and 3, they are alternating more or less to print. They run on separate CPUs, and now task 2 is done. And now task 3 is done, sorry, task 3 finished before task 2, and now task 2 is done. That, I hope, should be clearer.